Great seeing you here again. My name is Luc de Kuster, founder of the Kuster Academy. And in this new video, I'm going to talk about trigonometry. It's part of the Math Survival Guide. And in this video, I'm going to define the basic trigonometric functions, tangent and cotangent of an angle. But before we continue, don't forget to click on the subscribe button, click on the bell button. And every time we have a new video, YouTube will inform you about it. So let's have a look at the definition of the tangent and cotangent of alpha. When we look at a triangle, we still have the two rectangular sides, A and B, and the hypotenuse R, and the angle between A and R is alpha. When we look at the definitions we did before, we know that the cosinus of alpha is A divided by R, and the sinus of alpha is B divided by R. Now we can define the tangent of alpha, which is sinus alpha divided by cosine alpha. And we find this is B over R divided by A over R. And we can simplify because R is in the denominator of both values. This leads to B over A as the value for the tangent alpha. And we have to add that A cannot be equal to 0. Division by 0 is not allowed. Now, when we look at the cotangent, we can do the same, but the cotangent is tangent minus 1, the inverse of tangent. And we say that the cotangent is equal to cosinus alpha divided by sinus alpha. And we find A over R divided by B over R. And again, we can simplify because R is in both denominators, which leads to the result A divided by B, and for the cotangent, B cannot be equal to 0. Now let's have a look at the tangent and cotangent functions. Here we see the tangent function, we see the two elements over pi over 2. We don't have the value there, it goes to infinity. The same for pi over 2 to 3 pi over 2. And we see that basically the period in this case is pi. Like before, it was 2 pi. Now we have a period of pi, or 180 degrees. The next thing we're doing is the same thing, but now for the cotangent function. And we see that there is also a similar function. The function or the graphs are similar, but now we see that the cotangent is not defined in 0 degrees and pi. Again, we have a period which is equal to pi or 180 degrees. Let's have a look at the tangent and the slope of a line. When we have a line we defined before, we could define the slope by the definition of rise divided by run. And when we look at the definition of tangent alpha, we can say that tangent alpha is rise divided by the run, which is basically the slope of the line. Now in this case, what we can say, which is also very important, is that the tangent alpha is approximately equal to the angle for alpha smaller than 18 degrees or pi over 10. What is also important to understand is that we can say that this expression is in fact true when alpha is expressed as pi in a fraction of pi. We cannot use this for the angles in degrees. The next thing what we are going to have a look at are the signs of the tangent and the cotangent function. So we have the table, part of the table we showed before. We looked at the different quadrants. We already did this for sinus and cosinus. And in fact, we just have to multiply the values. So for tangent, since sinus and cosinus are both positive, tangent will be positive. When we are in the second quadrant, sine is positive, cosinus is negative. So we have the tangent which is negative, also the same for the cotangents. And we find in the third quadrant that the signs of sine and cosine are negative, so the tangent has a positive sign. And in the fourth quadrant, sinus is negative, cosine is positive, so we find a negative sign for the tangent. And for the cotangent, it's exactly the same sign because they're the same formulas, just inversed. We can also look at the values for sine, cosine, tangent, and cotangent. We can calculate them quite easily, and we see for the tangent with 0 degrees, we're at 0, 30 degrees, square root of 3 divided by 3, 45 degrees, tangent is 1, 60 degrees, square root of 3, and in 90 degrees there, the tangent is not defined. And for the cotangents, we have the same thing, but in the other direction. So for 0 degrees, there is no definition, cotangent is not defined there. Square root of 3, 1, square root of 3 divided by 3, and 0. So these are the numbers, the values for tangent alpha for some specifically known, very easy to remember angles. The next thing we can do is some exercise, and the first exercise we're going to look at the different values of alpha. We have 15 degrees, 75 degrees, 155 degrees and 284 degrees. You can now stop the video and do the calculation, and you will see if your calculations are correct. So you are back, you did the exercise, great. Let's have a look now at those numbers, what those values are, and you can verify them. So you see for 15 degrees, we find the sinus alpha is 0.2588, and so on. We do the same for the other angles, and we find the solutions for all these different angles. And you can see that the signs correspond with the place, with the quadrant in which we find those different angles. Another exercise is related to the slope. We have a line with a slope which is 1/3, and we want to find the tangent alpha, and see that tangent alpha is approximately equal to alpha when expressed in radians. So we take the triangle 3, 1, so we know that the slope is m, or tangent alpha is equal to 1/3, which is in fact approximately alpha when we are below pi/10, so alpha would be 0.333, and we're not really exactly in the conditions, but we're coming close to the conditions, and we see that basically when we look at the value of alpha in radians, it's coming close to 1/3. We're not there yet, but when we look at another example, it will be a lot closer. Like I said, when the angle alpha is small enough, we can use this approximation. So let's have a look at an exercise where we look at the grade of a road of 10%, which means that the rise is 10 meters and the run is 100 meters. The slope is 10 divided by 100, or 10%, or 0.1, which is clearly smaller than pi/10. And we can say that the tangent of alpha is equal to 0.1 radians. And alpha is about, or we can calculate alpha easily by 0.1 and dividing it by 2 pi and multiplying by 360, which gives us approximately 5.7 degrees. Why approximately? Well, I used the approximation of pi to be equal to 3.14, and that is not exactly correct. So that's it for the tangent and the cotangent function. We will continue with more trigonometric exercises and definitions. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye bye.